The ground shakes beneath you. The pictures rattle on the walls. You hear a rumble off in the distance. Then, boom, a deafening explosion. The shockwave blasts through the windows and sets off car alarms. You duck under the dining table for cover, but then you remember you live not far from a supervolcano in the middle of a tropical jungle. So, staying in one place isn't a good idea. The shaking finally halts. You take this chance to peek outside and see a giant cloud of smoke covering the sky. It's lunchtime, but you wouldn't know it. The sun is completely veiled and darkness falls. The power's out in the whole city. In this darkness, you see red molten lava shooting from the sky and spilling on the rim. You run outside along with dozens of your neighbors. Your priority right now, find safe shelter and fast. You think about taking the car, but with everyone running on the road, that's a no-go. So you run on foot where the crowd is going. Supervolcanoes are in a league of their own when it comes to natural disasters. Surprisingly, it's not all about size or height. A volcano is dubbed super if it erupts more than 240 cubic miles of magma. That's more than enough to overfill Lake Erie. It must also have a history of erupting and a magnitude of 8 on the Volcanic Explosivity Index. The largest active volcano on Earth is Hawaii's Mauna Loa. It's so big, it would cover the entire state of Rhode Island plus some. And next time you see a commercial plane flying high in the sky, remember that 30,000-some-foot altitude is about as tall as Mauna Loa is from base to summit. It's technically taller than Everest when you measure it like that, yet it's not considered a supervolcano. So you're running along the dark road not knowing and barely seeing where to go. Then, all of a sudden, a massive flaming boulder smashes through the bridge in front of you. You and everyone else are now stranded on the side of the volcano as it's getting more chaotic each second. Most of the crowd disperses, finding their own ways to safety. You remember there's a way to the other side not many people know about, but you'll have to cross a raging river through the dense jungle. You calm what's left of the crowd, and everyone follows you to your secret getaway. You finally get out of the city limits and head into the jungle. With the sky already dark, the tall trees and thick leaves make it almost pitch black. Everyone gets out their phone flashlights to navigate through the dark path. You all need to stick together and make sure nobody gets lost. Suddenly, fiery rocks strike the trees not far from you. Everyone jolts and tries to rush ahead, but nowhere is safe when it's raining scalding fire all around. You and your group have to pick up the pace or else. Imagine a typical avalanche or mudslide, very dangerous situations on their own. Now, imagine an avalanche of lava rocks and lava sliding down a mountain instead of mud. That's what's making its way towards you right now. More and more people catch up with your group and bring news that the entire neighborhood is submerged in lava. It's traveling quicker than you thought. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can move slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous problem. If you didn't have protection, the gases spewing from the eruption would fill your lungs, and those spread faster and further than the lava flow. Your eyes and throat would be itchy. You'd get a headache, dizziness, increased heart rate, difficulty breathing. The worst would be passing out from the lack of oxygen. Luckily, everyone managed to grab their gas masks before leaving their homes. You're now entering the treacherous terrain of the jungle and the danger zone. Everyone's phone batteries are giving out one by one, so your vision is even more limited. The terrain is tougher and you can't hear any sounds from the river. At this point, you're not even sure if you're going the right way. But your instincts tell you the deeper you go, the safer you'll be. The path is muddy, and the vines are hindering everyone's movements. That's when you hear something big running through the jungle. It's coming up on you fast. You can't see a thing until it's right up on you. A bear. And there goes a rhino. Wild cats, domestic cats, dogs, different creatures of all sizes and species. They all come running through the jungle right past you. You and your fellow humans aren't the only ones fleeing from the eruption. The rumbling is still going on. Before you know it, a shower of fire rocks strikes right behind you and ignites parts of the jungle. There's no going back. Everyone picks up and runs for it. You hear thunder in the distance. A flash of lightning lights up the dark sky. You think, finally, some rain to wash away this fiery nightmare. But that's not a regular storm brewing. These giant smoke clouds can mimic a thunderstorm under similar conditions. Your luck finally pays off. You hear the river straight ahead. You reach the bank and have to hop on some stones to get to the other side. You almost slip when someone from the group catches you just in time. Whew, that was too close. Not far down the river is a large waterfall leading straight to a shallow lake with sharp rocks at the bottom. The ash from the lava falls like snow, covering most of the trees and landing on the river. Ash is one of the most dangerous things about volcanic eruptions. You're soaked to the bone, but it's a lot better than ash and smoke. And then the rest of the group follow. The next thing you know, the river starts steaming as lava meets the bank and runs into the water. You try your best to speed things up. The lava can heat this water up to dangerous levels, and there are still people slowly crossing the river on the slippery rocks. Luckily, you manage to get everyone across. Well, almost everyone. You turn around and see someone's leg got caught between two rocks. The lava continues to pour into the river. You can feel the heat of the steam. You rush back to this person and try to pull them out. Their leg won't budge. Someone else from the group comes to help, and you're finally able to pull them out in the nick of time. You and everyone else, now exhausted from your trek, keep going as far as possible. That's when you see the main road that connects you to the broken bridge. There are others on the road that got out safely, and even some cars filling up with survivors and heading fast out of the area. The volcano is still spewing lava, and the entire city is flooded with it. What was once your town now looks like a giant burning lake. Planes and helicopters can't fly because of the smoke and ash, so don't count on an air rescue. You're still at risk even though you're on safer ground, so it's still too early to celebrate. Everyone continues to move away from the city. The further, the better. The ground continues to shake, but this time it's even more intense than before. Supervolcanoes are powerful enough to cause many earthquakes. But it's a good thing you're out in the open, far from the buildings and debris in the city. Now, back to reality. Rest assured that a volcanic eruption of this intensity won't happen for a very long time, as in millions of years. Besides, thanks to warning systems and humanity's preparation for such an event, it's extremely rare for even a regular volcano to do as much damage as it could. So, don't scratch Yellowstone off your travel list just yet. When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone. the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60, but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts. The largest volcanic region on Earth is not in Africa or Japan, but under the ice of Antarctica. Scientists found 138 volcanoes in its western part, and if they decide to go wild, you'll surely notice it. They could melt huge amounts of ice that will move into the ocean, raise its level, and make our planet uninhabitable for humans. But before you pack your things to fly away to another planet, hear me out. Only 2 of the Antarctic volcanoes are officially classified as active now. And it would take a whole series of eruptions, decade after decade, to seriously impact the whole world. Mount Erebus, one of the 2 Antarctic volcanoes currently in action, proudly bears the title of the world's southernmost active one. It has been continuously erupting since at least 1972. It emits plumes of gas and steam and sometimes even spews out rocks, and scientists call it Strombolian eruptions. One of the coolest features is a lava lake in one of its summit craters, with molten material on the surface. Such lakes are rather rare because they need certain conditions to make sure the surface never freezes over. The second active volcano is Deception Island, a horseshoe-shaped landmass. It is the caldera of an active volcano that last erupted over 50 years ago. Scientists who monitor it say it shouldn't go wild anytime soon. Antarctica also has plenty of fumaroles. Those are volcanic vents that release gases and vapors into the air. In the right conditions, they can spew out enough stuff to build fumarolic ice towers up to 10 feet tall. Scientists keep an eye on the Antarctic volcanoes with seismometers that detect when the Earth starts trembling from volcanic activity. Sometimes they also use more complicated tech, but it's all really challenging because of how far away this polar region is and how tricky it is to get there. That's why no one can predict when one of the continent's volcanoes that are now sleeping might erupt. We can guess what this waking up would look like if we analyze the events from nearly 20,000 years ago. So, shall we? One of Antarctica's sleeping volcanoes, Mount Takahe, had a series of eruptions and spewed out a good amount of halogens rich in ozone back then. Some scientists say these events warmed up the southern hemisphere. Glaciers started to melt and help finish the last ice age. For these events to repeat, we'd need a series of eruptions with substances rich in halogens from one or more volcanoes that are now above the ice. It's an unlikely scenario, but since it already happened in the past, it's not completely impossible. As for volcanoes hiding under a thick layer of ice, it looks like their gases would hardly make it to the atmosphere. but they would be strong enough to melt huge caverns in the base of the ice and produce a serious amount of meltwater. The West Antarctic ice sheet is wet and not frozen to its bed, so this meltwater would work as a lubricant and set the overlying ice into motion soon. The volume of water that even a large volcano would generate in this way is nothing compared to the volume of ice beneath it. So a single eruption wouldn't make a difference. But several volcanoes erupting close to or beneath any of the western Antarctica's big ice streams would. Those ice streams are rivers of ice that take most of the frozen water in Antarctica into the ocean. If they change their speed, then bring unusual amounts of water into the ocean, its level will rise. As the ice would get thinner and thinner, there would be more and more new eruptions. Scientists call it a runaway effect. Something like that happened in Iceland. The number of volcanic eruptions went up when glaciers started to recede at the end of the last ice age. So it looks like, for massive changes, several powerful volcanoes above the ice with gases full of halogens need to get active within a few decades of each other and stay strong over many tens to hundreds of years. Antarctica stores around 80% of all the fresh water in the world, and if they melted all of it, global sea levels would rise by almost 200 feet. And then we'd have to look for a new planet to live on. But this again is an unlikely scenario. It's more likely that the eruptions under the ice will lubricate ice streams and seep water into the ocean, but it wouldn't be the end of the world. A super strong, super angry supervolcano could do it though, and it has already happened in the past. Over 200 million years ago, the world went through a major makeover with not one, not two, but 4 massive volcanic eruptions in huge pulses. The supervolcano called Camp had been erupting over and over for 600,000 years. It all happened in Wrangell, a large chunk of land that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. And it wasn't the lava or the volcanic ash that ruined the environment. The eruption made carbon levels skyrocket. The planet would never be the same again. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in Asia to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels. It made the atmosphere toasty, and the rain poured down. So the bad news is, another eruption like this could happen. The supervolcano beneath Yellowstone National Park has been sleeping for nearly 70,000 years. But if it wakes up, it would be many times more catastrophic than the eruption of Mount St. Helens in 1980. It's considered the most disastrous volcanic eruption in U.S. history. It followed 2 months of earthquakes and injection of magma below the volcano that weakened and destroyed the entire north face of the mountain. The eruption column went 80,000 feet into the atmosphere and spread ash over 11 U.S. states and several Canadian provinces. The last Yellowstone eruption was 1,000 times greater than that. The ground above Yellowstone sits on a hot spot made of molten and semi-molten rock called magma. This magma stuff flows into a chamber beneath the park, about 4 to 6 miles down, making the ground puff up like a balloon. But then, as it cools down, the ground goes back to its usual state. Volcano watchers have been keeping an eye on this for a century. They noticed the ground lift up about 10 inches around 20 years ago, but since 2010, it's been going back down. The experts say we have no big eruptions on the horizon, so doomsday isn't coming anytime soon. But there's some underground activity going on lately which keeps us interested. Since humans haven't been around to witness every little thing Yellowstone does, it's kind of tough to say for sure what's brewing down there. Yellowstone has had some epic eruptions within the last couple million years. They happen like clockwork, with gaps of 600,000 to 800,000 years between them. The last big one was around 640,000 years ago, and it basically reshaped the entire landscape, spreading ash and debris as far as Louisiana. You can still see the aftermath of the last big eruption in the Yellowstone caldera today. Experts say a massive eruption, like the last one, is an unlikely scenario. We're more likely to see eruptions of steam and hot water or lava flows. When and with what force it will wake up remains a mystery to scientists. Guaijen Volcano in Indonesia is not your ordinary lava-belching mountain. Instead of producing black smoke and red lava, as most volcanoes do, this eccentric guy lets out a blue flame and electric blue lava. This phenomenon occurs because the volcano contains some of the highest levels of sulfur in the world, and when the sulfuric gases interact with scorching air and get lit by the molten lava, they start to turn blue. Unfortunately, you can see this mesmerizing sight only at night, but you can smell it all day long. By the way, the world's largest acid lake is also located inside this crater. The Dead Sea has a high concentration of salt and minerals compared to other seas, even though it's technically a lake. Swimming is almost impossible, but people go there for the natural chemicals for the body. Floating on the surface is a great way to relax. This ancient body of water got its name because no macroscopic organisms can live there since it's 9.6 times saltier than oceans. Only a few bacteria and fungi can be found enjoying the salt. It's also Earth's lowest elevation on land at 1,400 feet below sea level. An underground crystal cave exists in Mexico, and it looks like some interstellar world. It's roughly 1,000 feet beneath the surface, with each spike measuring up to 35 feet in length and weighing up to 55 tons. These are some of the largest crystals in the world. Luscantire Beach is an endless strand of white sand dunes and azure water. But don't let the tropical vibes fool you. It's located in Scotland. That's why it mostly looks like this during May and June only. In December, the place gets only an average of 1 hour of sunshine per day, making it way more dramatic and monochrome. The Georgia Guidestones is a collection of giant stones in a star pattern. It has inscriptions in 8 languages, including Hindi, Chinese, and Swahili. It also has an astronomical calendar finished in 1980 and was built to last centuries. No one knows who built it or why. All the way over in sunny California is Sequoia National Park, home to the giant forest. It's been around for thousands of years. More than 8,000 of these colossal trees rule the land, including 10 of the largest living plants in the world. The General Sherman sequoia is estimated to be up to 2,700 years old and is recognized as the world's largest known living tree by volume. The famous stone heads of Easter Island have been around for hundreds of years. No one knows exactly why they were built. Some scientists think that local people believe the statues would make the soil more fertile. Soil analysis proved the heads did their job well. It's the best agricultural spot on the island. The chemical composition of the ancient hot springs in Pamukkale, Turkey, makes the water pouring over the edge look magical. They're not only good for cleansing your body, but the mind too. All the way in Saudi Arabia is a rock sliced perfectly in the middle with 2 pieces sitting parallel. What makes Al Nasla so unique is that it wasn't artificially done, but is a result of nature's work over the years. Now, this glacier may look like someone dropped tons of red paint in the middle of Antarctica, but it's actually the natural color. Blood Falls is a result of extreme salted water mixed with iron oxide, giving out this eerie vibe in the middle of nowhere. In early May 2018, New England observed one of the scariest and most dangerous phenomena ever, a super long-track tornado. The frightening natural phenomenon started not far from Charleston, New Hampshire, and traveled toward the town of Webster in Merrimack County. It took the tornado 33 minutes to cover 36 miles and become the 3rd on the list of the longest track tornadoes in New England. In the Philippines, you can swim in some of the most crystal-clear waters and discover an underwater world below you in the province of Palawan. The municipality of Coron has white sandy beaches with many small boats riding through the many amazing sceneries. Tristan da Cunha is a small volcanic archipelago in the Atlantic, with the only neighboring cities of Buenos Aires, Argentina, and Cape Town, South Africa. It takes 7 days by ship to get to this unique place. If you want to escape from the rest of the world, staying with the 280 locals will make you feel like you're away from everything. During the first week of January 2018, unusually cold weather in the northeast United States froze the Atlantic Ocean in North Falmouth, Massachusetts. What's more, the ocean was frozen so thoroughly that people were walking on the waves. Now, that's obviously something you don't see every day. Red sand is what makes this beach unique and why tourists flock to Tianjin, China. A red-colored plant called a sueda salsa dwells in the saltwater. The whole beach is covered in red, with only the top layer of the sea visible. If there ever was a thing that said, "I defy gravity" out loud, it's the stone of Damasco in Argentina. The huge 300-ton boulder stands precariously on the edge of a cliff and rocks a little bit from side to side in the wind. People even checked it by putting glass bottles under one of its edges. They exploded with another movement of the rock. Unfortunately today, you can't see this wonder of nature as it was a century ago. In 1912, the boulder suddenly dropped from its perch, which it had occupied for literally hundreds of years. The people of the nearby town of Tandil were so sad about this event that 95 years later, in 2007, they decided to restore the stone. They made a plastic replica of the rock and put it on the same spot and even in the same position. So, even today, coming by Tandil, you can see its famous balancing boulder. More of a symbol now, of course, because it's no longer rocking and only weighs 9 tons, but instantly recognizable nonetheless. Socotra is an alien-like island off the coast of Yemen in the Indian Ocean, with one of the most unique trees ever seen. It's called the dragon tree, and it can only be found on this amazing island. In 2008, it was labeled as a World Heritage Site. If you ever see a tight burning column of air, don't panic, it's not the end of the world. The creepy combination of whirlwind sounds and scorching inferno means that you have crossed paths with a fire tornado, also known as fire twister or fire whirl. This dangerous phenomenon occurs mostly during wildfires. These fires create a big area of superhot air just above the ground. When this scorching air gets mixed with the cooler air higher up, it results in a whirlwind that churns up burning debris and flames. The most powerful firenados can stretch hundreds of feet into the air. The House of Mystery in Gold Hill, Oregon, amazes its visitors with gravity-defying effects. You can't stand straight there, always leaning to the side and having to hold on to something for balance. Balls roll upwards. There's also a broom that stands perfectly still wherever you put it, unlike virtually everything else in the shack. The local Native American tribes called this place the Forbidden Ground, even before the house was built there, and they avoid approaching it. The owners of the shack, though, decided to turn it into an attraction, and they succeeded. They created an atmosphere of mystery around the place, and spread the news about it in newspapers and later on the internet, and voila! A perfect anomaly is made. In fact, it's no more than a curiosity. A human-made optical illusion that tricks your eyes and other senses. Now, if you travel to the Philippines, Indonesia, or Papua New Guinea, you'll have a chance to see some of the most unusual and cheerful trees in the world. The trunk of the rainbow eucalyptus looks as if it had been painted orange, green, red, purple, yellow, brown, blue, hey, you name it. Some trees are so bright that they seem artificial. The rainbow eucalyptus regularly sheds strips of bark, which reveals a bright green layer underneath. A bit later, this green layer gradually changes its color, and since the shedding happens at a different time in different places on the trunk, the tree starts to look multicolored and very attractive. Yemen is home to the oldest skyscrapers in the world and the oldest metropolis. The ancient city of Shabam is considered to be the Manhattan of the desert, due to the collection of mud buildings popping out of the desert floor. It used to be a caravan stop during ancient times. Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why." Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate, and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be in danger, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry? Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water. which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps, each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.
Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where 2 pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the 2 plates can lock together. which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn! The latest super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock it would be enough to cover the entire United States to the depth of a one-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates, but so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. Over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius, that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows, dense masses of super hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agun, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows. which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano.
The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international dateline, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere. So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's the reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha! Loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster. Park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe? But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore, and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate.
On a sunny day, a man was diving in shallow waters near South Africa. At one point, he saw something that didn't catch his eye at first. A pile of shells that looked as if it had been put together. Maybe by some other diver, he must have told himself. But out of all these shells came the most unusual of creatures, an octopus. The gorgeous underwater animal looked straight at the man before swimming away. Impressed by his new acquaintance, the diver started visiting the octopus every day. He watched it use shells and seaweed to protect itself and learned how it hunted and cared for its eggs. All these encounters became the basis for a now famous documentary. In the movie, the diver wanted to study the relationship between a wild octopus and its observer. Initially, the octopus was a bit too shy to let the man get close. But over time, it began to trust him and even explored his body. At one point, the octopus even rested on the diver's chest. The man soon began to look at the underwater creature as his octopus friend. Sure, the documentary did make it look like a true friendship, but that was most likely because of all the close-ups and eerie music. But you can't really know what the octopus is thinking. Maybe what looks like tenderness is just curiosity or confusion. Maybe an apparent hug is really just a defense mechanism. Some people may love octopuses, but can they really be friends with a human? Until they learn to talk, I guess we'll never know. That doesn't make an octopus less of an interesting creature, though. Apart from those quirky sets of tentacles, obviously, octopuses have another characteristic that sets them apart from other sea creatures. A recent study that involved studying the footage of octopuses living underwater shows that they sometimes develop this unusual behavior. They seem to throw things at each other on purpose. It can be anything from dirt from the bottom of the sea to shells or rocks. Octopuses are known to be solitary creatures, so when something or someone, like an underwater camera person, gets too close to them, they might lash out. Just as we have yet to discover the limits of our galaxies and constellations, we know very little about the bottom of the sea. It's one of the reasons why we find it so hard to explain the behavior of some underwater creatures. The truth is, we don't have good enough technology able to deal with harsh conditions and a limited amount of light underwater. You might have asked yourself at one point, what's the deepest part of the ocean? It's called the Mariana Trench. We don't really know exactly how deep this giant hole is, since it's too difficult to measure, but it's somewhere around 6.8 miles deep and 5 times longer than the Grand Canyon. This massive underwater trench was first studied back in 1875 with the help of a weighted rope. Back in 2012, a Canadian film director reached the bottom of the trench in a submersible vessel called the Deep Sea Challenger. Some of the most bizarre creatures on the planet were discovered here, including the Dumbo octopus, the sea cucumber, and the goblin shark. The Mariana Trench got its name from the nearby Mariana Islands, which were named Las Marianas in honor of Spanish Queen Mariana of Austria. The Mariana Trench might be the deepest part of the ocean that we know of. But one other mysterious phenomenon that's interesting for researchers is called phantom bottoms. In the late 1940s, when the sonar became standard equipment, ships and submarines noticed unexpected signals coming from the ocean. Those signals came from areas where no seafloor was supposed to exist. What's even more mysterious is that this fake seafloor appeared to move. One researcher at Scripps University found out that these phantom bottoms showing on maps were indeed alive. They were made out of a layer of jellyfish, shrimps, and other deep-sea creatures. The reason why they move is that they rise to the surface at night to feed. To top it all off, even the way these creatures move is kinda calculated. They don't just move randomly, but seem to gather together by species. We used to believe underwater animals behave this way only to avoid being caught by predators. It's a mystery to scientists why they group in the same way to form a fake seabed. Our curiosity about the deep waters doesn't stop at the seafloor. If you went on a vacation to the beach when you were young, you probably remember the fun of digging in the sand. As the hole got deeper, you may have asked yourself, could I dig all the way to the other side of the Earth? None of us have ever found out. Our parents took us home when it got dark and chilly. Scientists are more reasonable when it comes to this subject. For starters, they know the best place to start digging would be underwater, since those regions are already deeper than what we can find on land. They also do not have the ambition to drill a tunnel through Earth. It's not even possible. That's mostly because of the extreme heat and pressure inside our planet. Even if we could technically dig a tunnel, it would not be safe to travel through it. However, reaching the mantle and retrieving a sample would be a huge scientific achievement, similar to landing on the moon. What we live on is called Earth's crust. Underneath it, there are other layers called the mantle, outer core, and inner core. Researchers have been trying to drill into Earth's mantle since the 1960s, but they haven't succeeded. Some failed due to technical issues, and others were unlucky and chose the wrong places to drill. Our planet's mantle is made of molten rock. Wouldn't that be dangerous if we ever reached it? Scientists say we have nothing to worry about, though. If and when the drillers eventually pierce through the crust underwater, hot molten rock won't pop up the hole and spill onto the seafloor like it would during a volcanic eruption. Mantle rocks aren't solid, sure, but they move slowly, at the same speed as your fingernails grow. Another of those famous deep-sea mysteries is that of the 1997 bloop. You heard that right. I'm talking about a weird sound that seemed to come from deep under the waves. People heard it in the South Pacific. No one had ever recounted a sound like that before. Some thought it must have been emitted by a strange creature living deep in the ocean. It didn't help that the noise came from a location mentioned in a story by famous writer H.P. Lovecraft. In his story, it was a creature called Cthulhu that lived there. In the novel, the author described it as a large, human-like monster with tentacles on its face and wings on its back. For many years, people tried to figure out where the noise came from. It wasn't until 2005 that they concluded it was from icebergs breaking off of glaciers. Some people still don't believe that this explanation truly makes sense and are searching for a different reason for the bloop. If creatures living outside of our planet ever decided to come to visit, you wouldn't expect them to go straight to the bottom of the sea, right? Well, some people claim there's a sort of spaceship on the ocean floor, discovered in 2011. It's basically an oval-shaped object located on the bottom of the Baltic Sea. In 2012, a team of divers explored the anomaly and found what appeared to be a staircase and other structures on its surface. This only added to the belief that the large object had been made by someone and wasn't just a natural phenomenon. Even more bizarre, close to the unidentified anomaly, the explorers' electrical equipment, like sonar instruments and satellite phones, started to malfunction. Some scientists believe it just to be a glacial deposit or some other natural formation, but they still don't know for sure what it is. Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city. Except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system.
Whoa! Earth's surface is shaking. Long cracks split the ground open. Lava rivers are rapidly flowing down the slopes. Deafening noise is filling the air. Rocks and other debris are flying high up. Clouds of volcanic gas and ash cover the sky. Now, this is not a plot of a blockbuster disaster movie. It's what happens when supervolcanoes decide to erupt. But this is likely not the scenario that will take place when the world's largest volcano, Mauna Loa, decides to finish its long nap. In 2021, scientists were sure it would happen soon, but so far, nothing. The volcano's seismicity keeps increasing and then going back to normal, but you never know when this giant will finally come back to life. That's why experts have been monitoring geological activity on Hawaii's largest island for quite some time. The Big Island of Hawaii is made up of 5 volcanoes, including the most active on the planet, Kilauea, and the largest, Mauna Loa. This gigantic thing makes up almost half the landmass of the island. And what lava Kilauea emits in one day, Mauna Loa could spew out within 20 minutes. That's what it did in 1984. While Mauna Loa's smaller sibling has been throwing tantrums for a while, the giant has been slumbering ever since its last eruption. But very recently, the Hawaii Volcano Observatory has recorded more than 200 mini-earthquakes below Mauna Loa. It likely means an increased flow of magma down there. Good morning! The volcano might be waking up. Or not. If Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places, like Captain Cook, very quickly, in a matter of hours. In 1984, the last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where a campus of the University of Hawaii is found. Luckily, people had a few weeks' warning to get ready for the disaster. These days, locals have special go bags ready with the most important stuff, including documents and money. Such precautions can come in handy in case of an emergency evacuation. Even though most Mauna Loa eruptions have so far only affected the summit area, several of them sent lava all the way down to the ocean, and you never know how powerful the next eruption will be. Now, what is the highest mountain on Earth? Mount Everest, you say? Well, it depends. From seafloor to the summit, Mauna Loa is 1,000 feet taller than the famous Himalayan peak. The volcano is so big, it makes the Pacific plate it's sitting on literally slump under its weight. Scientists say that when this monster of a volcano erupts, the volume of lava coming out per unit will be life-threatening. Over its recorded history, Mauna Loa has been erupting regularly, almost every 6 years. And even though the last eruption of the volcano occurred about 40 years ago, scientists are certain it'll happen again. Now, remember the scene I showed you at the beginning? Well, you can relax. It's not likely to happen with Mauna Loa. The thing is, big island volcanoes, including Mauna Loa, aren't very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes get formed by very fluid lava. It travels farther and forms much thinner flows than lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So if, or should I say when, Mauna Loa erupts, there probably won't be ash clouds and tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast. Using theoretical vent maps, experts from the Hawaii Volcano Observatory have made charts of possible lava flows. They're kind of worried about earthquakes clustering at high rates. It likely means that lava is on the move under the surface. 500 to 600 earthquakes per day are a serious reason to be on high alert. On the other hand, it doesn't necessarily mean a disaster or inevitable eruption. Around a decade ago, several earthquakes that happened at the same time signaled that something was happening under Mauna Loa. But an eruption didn't occur. Instead, half the volcano shifted a bit to the south. This way, it probably gave more room to magma so that it had enough space to stay beneath the surface. Now, let's get back to the catastrophic eruption we saw at the beginning of the video. That's what often happens when a supervolcano erupts. Those are volcanoes that have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually found over hot spots. Supervolcanoes can produce super eruptions, and when they do, they blow more than 240 cubic miles of ash, molten rock, and hot gases up into the air. In other words, 4 super eruptions could fill the Grand Canyon to the brim. Supervolcanoes get formed when gigantic volumes of scorching hot magma are trying to escape from deep underground. This magma rises close to the surface but can't break through Earth's crust. That's why a huge pressurized pool of bubbling magma gathers at a depth of only several miles. The pressure keeps growing because more magma is trying to get to the surface until, bam, a super eruption occurs. The most recent super eruption happened in New Zealand. Well, when I say recent, I mean around 26,500 years ago. Nah, I wasn't around then. That's when a supervolcano beneath the surface of Lake Toba spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Toba volcano simply didn't go off like many others. At first, everything was going as usual. More than 200 square miles of magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first part of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground, and thousands of tons of lava, rocks, and ash flew high into the atmosphere. But the age of supervolcanoes isn't over. The most infamous of them all is probably the one in Yellowstone National Park. This giant handles at least 3 mega-powerful eruptions, and who knows how many smaller ones. If this monster erupted anywhere as strongly as it did 2.1 million years ago, it would spit out more than 588 cubic miles of red-hot material. You can probably picture it more vividly if I tell you that this volume is comparable to 65 million Capitol rotundas in Washington, D.C. piled together. Wow. Anyway, scientists are sure that Yellowstone doesn't present any danger these days. For an eruption to happen, magma inside must be at least 50% molten. With the Yellowstone caldera, this number is just 5 to 15%. But of course, Yellowstone isn't the only supervolcano on our planet. There's also New Zealand's Toba you already know about, Japan's Eruption, California's Long Valley, Indonesia's Toba. Any of them can one day produce a super eruption. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced anything like a super eruption. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperature made the volcano blow up with a deafening boom. It was clearly heard 2,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us. Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes caused tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those. Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps, each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans and you get a geoid. In reality, the line stretches across oceans as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic.
If you've ever been to Yellowstone National Park, you were probably mesmerized by its geysers, which spew superheated water and steam high into the air. But an even more intriguing thing actually hides underground. I'm talking about that underfoot plumbing system that makes those grand eruptions possible. About that, there's good news. Recently, researchers have succeeded in mapping the national park's hydrothermal plumbing system with the help of a giant flying magnet. As a result, scientists have managed to document all these features in stunning detail. The thing is, Yellowstone houses the world's largest hydrothermal system. It contains over 10,000 features, like geysers, mud pods, hot springs, and steam vents. They're fed by a network of underground water pathways. Those get overheated by magma flowing underground. It causes the water to rise to the surface. Now, no one actually knows much about the workings of this system, but the newly created maps might finally shed light on it. Experts explain that their knowledge of Yellowstone has a subsurface gap. That's why it's often called a mystery sandwich. Scientists know quite a lot about the features on the surface because they can observe them directly. And they know what's going on in the magmatic and tectonic system several miles below the surface. But they haven't figured out what's happening in the middle yet. So, I must tell you about that giant flying magnet used for research. It's known as SkyTem. It was attached to a helicopter and flown over Yellowstone several hundred times, scanning the ground below. The magnet is made up of an 82-foot-wide charged wire loop. Its main task is to generate a strong electromagnetic field. And since different kinds of material, like water or rock, respond to this field differently, scientists managed to create a few subsurface maps for the first time ever. The mapping technique also allowed the researchers to differentiate between magma and bedrock, since they have a bit different magnetic properties. And the team got a chance to see how the magma and water interact and create those mind-blowing geological features on the surface. The team got high-resolution maps to a depth of around 500 and 2,300 feet, and low-resolution maps showing what's going on at a depth of up to 1.5 miles. At the same time, the researchers think that the hydrothermal system itself may stretch as far as 3 miles below the surface. If they're right, it means they've only mapped the top half of Yellowstone's plumbing system. Anyway, remember how I said that scientists know pretty much about the bottom part of the Yellowstone sandwich? They have such a good idea about the tectonic plates and deep fault lines because the park's frequent earthquakes provide them with a lot of opportunities to study different phenomena. In July 2021, for example, more than 1,000 earthquakes rocked the area. These days, the team of researchers knows much more about some famous features, like the Old Faithful Geyser or the Grand Prismatic Spring. They've also found out that individual hydrothermal features on the surface can actually be connected to others, which can be as far as 6 miles away from them. Another interesting discovery is that even though Yellowstone geysers and hot springs vary in size, shape, color, volatility, and chemical composition, they are mostly fed by very similar underground sources. That means that the difference between the features appears closer to the surface. Now, I'm sure you've seen the iconic image of Yellowstone with a large rainbow-colored spring, fiery orange at its edges. So what makes these hot springs so colorful? Surprisingly, these awesome hues come from microscopic creatures. The temperatures in the springs are so high, they can easily and quickly cook you. Plus, the water there is super acidic, like the liquid in a car battery. But there are certain types of heat-loving microbes that don't mind these crazy conditions. You can even say they're thriving there. So every ring of a different color is, in most cases, a ring inhabited by different bacteria. And each species is adapted to a particular temperature or pH level, which measures how acidic this or that environment is. For example, take the Grand Prismatic Spring, yes, the iconic one. Its rainbow hues likely hint at the diversity of microbes living there. So, starting from the center of the hot spring, you can see a beautiful aquamarine color there. That's where the water temperature is the highest, reaching 189 degrees Fahrenheit, because this area is right over the underground water source. The water there is too hot even for microbes. That's why what you see is mostly clear water. As for the reason for its blue color, it's the same as why the sky is blue. Sunlight hits the surface of the water and the light scatters, but the blue light scatters the most, getting reflected back to your eyes. Now, the next ring of color is yellow, all thanks to certain cyanobacteria. The temperature in this yellow ring reaches 165 degrees Fahrenheit. If the conditions in the hot spring were a bit different, these bacteria would create a blue-green hue, thanks to a green pigment called chlorophyll. But since the sunlight hitting the spring is too intense, the bacteria start producing another type of pigment. It's called carotenoids. And guess what? It acts as a sunscreen for the bacteria. And since this pigment is orange, the normally green bacteria get a yellowish hue. And finally, we've got that bright orange color closer to the edges of the prismatic spring. It's a bit cooler there, around 149 degrees Fahrenheit. In this part of the spring, you can find several types of bacteria. They all produce substances that give the spring this bright orange color. And finally, right at the edges of the spring, the temperature is cooler, around 131 degrees, and a greater variety of microbes can survive there. All of them combined give the edges of the spring that red-brown hue. But scientists believe that people and their activity may have influenced the colors of Yellowstone's hydrothermal features. For example, in the past, the temperatures in the Morning Glory pool used to be much higher than they are today. That's why its color was a deep blue. But trash has started to accumulate in the pool, and some of it clogged the vent. This caused the temperatures to drop, which led to microbial growth. As a result, that pretty blue color turned into orange-yellow. As for Yellowstone's geysers, the most famous one is called Old Faithful. It got this name at the end of the 19th century because of how regular its eruptions were. This geyser is more active than the others, erupting about 20 times a day. Each of these magnificent events lasts from 1 to 5 minutes, and the fountain of steaming water can reach a height of 180 feet. Now, while talking about Yellowstone National Park, we can't but mention Yellowstone supervolcano, right? Supervolcanoes appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. You don't necessarily want to be around for that. Over the past 50 years, the Yellowstone caldera has risen almost 3 feet. It shouldn't alarm you, though. Experts are sure it's a natural behavior for Yellowstone. Periods of dome-shaped uplift are followed by the caldera lowering. Scientists think the supervolcano doesn't present any danger at the moment. For an eruption to happen, the magma inside has to be at least 50% molten. With Yellowstone, this number is just 5 to 15%. Even better, a recent study made the researchers believe the hotspot might be in a state of decline right now, even despite all the breathing and dome-raising activity. There have been at least 3 other super eruptions in the history of Yellowstone volcano. They happened 2.1 million, 1.3 million, and 640,000 years ago, long before video. The most recent super eruption was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spilling out 240 cubic miles of rock, dust, and volcanic ash. No thanks, I'll pass. About 800,000 years ago, I wasn't around then, a gigantic asteroid soared through space and plummeted toward Earth. It slammed into our planet with enormous force. It blanketed 10% of Earth with shiny black and green lumps of rocky debris known as tectites. Tectites are pieces of rock that get liquefied by the heat of a meteorite impact. Then they cool down to look like dark, glassy pebbles. A trail of these tectites was strewn across Southeast Asia and reached all the way to eastern Antarctica. This is how scientists know this giant meteorite crash happened. Well, researchers spent nearly 100 years trying to find the gigantic crater caused by the impact. But tectites were too widespread. That's why they couldn't pinpoint the exact location. Until recently. A team of experts from different universities tried to discover the ground zero of the meteorite impact. They investigated several craters in China and Cambodia, but none seemed to be created by a meteorite crash. The experts then decided to investigate Laos. It's a country where they discovered the largest and most concentrated number of tectites. After ruling out all visible craters, the team came up with a new theory. What if the crater is hidden by something? In search of the potential crater, the scientists measured gravity readings at different locations all across Laos. At the site of an ancient volcanic eruption, below thick, dense layers of cooled volcanic lava, they discovered a severe gravitational anomaly. It turned out to be a large, elongated crater, over 300 feet deep and spreading 8 miles wide and 11 miles long. Based on the location and the crater's enormous size, scientists believe this is the impact site of the ancient meteorite. Meanwhile, over 2 billion years ago, long before the age of dinosaurs, Earth was struck by one of the largest asteroids to ever hit our planet. The asteroid was approximately 6 to 9 miles across and created the biggest impact crater on Earth. This is the Vredefort crater. You can find it in present-day South Africa. When it was formed, it had a gigantic diameter of 186 miles. Over the centuries, the massive crater slowly eroded away into the Vredefort Dome. That's a rocky hill formation that was the central site of the asteroid's impact. This formation is so large that it can be seen from space. Today, the Vredefort Dome is a recognized World Heritage Site. It's also home to several towns and communities that encourage tourists to come and visit the ancient crater. In 1943, one pilot strayed from his regular flight path to avoid dangerous weather conditions. Flying over Quebec, Canada, he spotted a large, perfectly circular basin. That is how the Pingualuit crater was discovered. Around 1.4 million years ago, a meteorite hit this spot, creating this small but deep impact crater. It has a diameter of 2 miles and a depth of 1,300 feet. A lake of deep blue water has formed at the bottom of the crater. It's said that this lake contains some of the purest water in the world as it has no inlets or outlets. It means that the lake is only filled by rains and melting snow. The lake is home to one species of fish, the Arctic char. The Sudbury Basin is also in Canada. Formed over 1.8 billion years ago, it's one of the largest and oldest impact craters in the world. It's located in Ontario, but the impact from the collision was so powerful that debris from it was found 500 miles away in Minnesota. Unlike most impact craters that have a circular shape, the Sudbury Basin is an oval. It's 39 miles long with a width of 19 miles. The original impact site might have been a whopping 10 miles deep, but its modern-day version is much shallower. The asteroid that created the basin carried a high concentration of natural minerals. This made the soil in the crater incredibly fruitful. Today, its floor is home to numerous fruit and vegetable farms. The unique crater formation of Sudbury Basin was used to train Apollo astronauts before they embarked on their missions to the Moon. Perhaps the most famous meteorite of all is the Chicxulub. That's the meteorite responsible for wiping out 75% of all plant and animal life on Earth, including the dinosaurs. The Chicxulub meteorite had a diameter of 6 miles when it struck Earth 66 million years ago. The crater now lies off the coast of Mexico, hidden deep beneath the seabed. It's around 93 miles across and 12 miles in depth. Recently, scientists managed to drill deep down into the highest peak of the impact crater to collect rock samples. They discovered that the disappearance of dinosaurs wasn't caused by the giant size of the meteorite or the scale of the blast. It was because of the exact location where the Chicxulub hit Earth. The meteorite struck part of our planet that was densely filled with a mineral compound called gypsum. It's a soft sulfate mineral that is typically used as a fertilizer. The collision blasted so much sulfur into the air that it blocked out the sun. This caused the prolonged dark winter that doomed the dinosaurs. One of the youngest craters on Earth is the Barringer crater in Winslow, Arizona. The Barringer crater is also one of the best preserved craters on Earth. It was formed 50,000 years ago when a heavy meteorite made mostly of iron plummeted down from space. Earth's atmosphere barely slowed down the massive chunk of metal. It collided with the ground with incredible force. The meteorite vaporized upon impact, leaving very few remains. The crater left by this powerful explosion was named after the man who identified it in 1903. It was a mining engineer named Daniel Barringer. The diameter of the crater is 3,900 feet and it goes 560 feet deep. The Barringer family still owns the impact site to this day. You can visit the crater and take a guided tour around its rim. The Papagai crater in Siberia is one of the most interesting craters on Earth. An asteroid impact over 35 million years ago formed this massive basin. The crater is 62 miles across, which makes it the fourth largest one in the world. This crater is unique as it's home to one of the largest diamond deposits in the world. The intense pressure from the collision transformed the graphite at the impact site into diamonds. Scientists say that the crater contains trillions of carats of diamonds, but no one has ever mined them due to the site's remote location and lack of infrastructure. In the year 1530 BCE, a meteoroid entered Earth's atmosphere before shattering into pieces. The meteorite's burning fragments rained down on Earth and crashed into the planet's surface. As a result, a group of craters appeared on a small Estonian island, Saaremaa. The largest crater is a 360-foot wide perfect circle. It's 70 feet deep and filled with blue water. 8 smaller craters that appeared during the collision can be found within a half-mile radius of the largest crater. The impact of the meteorite fragments caused the trees on the islands to catch fire. Almost all forests burned down. Luckily, the woodlands have now grown back, and the craters are a popular hiking destination for tourists. A meteorite struck the area we now know as Quebec, Canada, around 200 million years ago. This collision created the 6th largest impact crater in the world. It had a diameter of 40 miles. Over the century, the outer rim of the crater has filled up with water. It's now known as Manicouagan Reservoir. The impact crater lake is so large it can be seen from space, and its strange shape gave the lake its nickname, the Eye of Quebec. The oldest meteorite crater in the world is in Western Australia. The Yarrabuba crater is 2.2 billion years old. Well, that gets my vote for the best crater name. The impact site is so ancient that the original crater has completely eroded away. Yarrabuba's diameter was around 19 to 43 miles. Scientists managed to figure out the age of the impact site by analyzing the ancient crystals and minerals found within the crater. Brighter green plants might give us a warning when a volcano is stirring. Turns out, unlike earthquakes, which are super unpredictable, volcanoes can sometimes show early signs. Plants growing around volcanoes look healthier when volcanic activity ramps up because they thrive on increased carbon dioxide levels, a gas that volcanoes emit during eruptions and through underground magma. They also turn browner when the volcanic activity peaks, likely due to harmful gases and heat harming the vegetation. Scientists use satellites to figure this all out. They analyzed satellite data spanning from 1984 to 2022. Future changes might be tracked through satellite imagery as well. Now, this isn't easy to measure directly, especially when volcanoes are tucked away in hard-to-reach, lush areas, such as Taal Volcano in the Philippines and Mount Etna in Italy. This way, plants could give us a heads up about volcanic eruptions years before they happen. With this new, weird method, we could save nearby communities by enhancing safety measures, minimizing property damage, and improving evacuation plans. Volcanoes and plants are often tied in mysterious ways. For example, volcanic eruptions in Krakatoa, Indonesia, gave a surprising boost to saguaro cacti in Arizona's Sonora Desert, even though they're thousands of miles away. When the infamous Krakatoa volcano erupted in the 19th century, it sent shockwaves around the world and suddenly helped nurture a generation of saguaros. These incredible cacti can be up to 40 feet tall as adults, but they start life as tiny seedlings that struggle to survive in the desert's harsh conditions. However, thanks to the cooler and wetter conditions caused by volcanic eruptions like Krakatoa, they can get unbelievable growth spurts. Chillier summers and milder winters that follow such eruptions create perfect conditions for young saguaros, which usually don't make it due to extreme heat and cold. But volcanoes not only influence plants, they're also Earth's jewelry makers. Deep beneath the surface, in the fiery heart of a volcano, conditions are just right to form dazzling gems. When volcanoes erupt, they can bring these treasures up to the surface. One of the most famous gems created by volcanic activity is the diamond. They're usually found in rare type of volcanic rock called kimberlite, which forms deep within the Earth under extreme pressure and temperature. Millions of years ago, kimberlite eruptions, small but powerful volcanic events, hauled diamonds from deep within the Earth. This created sources for many of today's diamond mines. Now, these eruptions didn't happen just anywhere, but originated from the stable hearts of continents, known as cratons. They were bursting forth from as deep as 75 miles underground. Fueled by a mix of carbon dioxide and water, they were like natural rockets, blasting through the Earth to form carrot-shaped channels filled with diamond-laden rocks. Recently, scientists have delved into why these eruptions happen. They suggested that the breakup of ancient supercontinents like Pangaea disrupted the mantle's flow underneath, triggering these spectacular kimberlite eruptions. When a volcano that hosts kimberlite erupts, it can propel these precious stones toward the surface, where we eventually find them. There are other gems that can be found in solidified lava, like peridot, a bright green stone that forms in the molten rock of the upper mantle and is brought to the surface by volcanic activity. There's also obsidian, a shiny glass-like rock that forms when lava cools rapidly. And then there are some insane rocks, like the ones that can hold water in them, even in lava. The deeper we dive in volcanoes, the rarer are the gems we can find. If we dive into the thick layer known as the mantle, we might find olivine, a resilient, pretty green mineral that makes up about half of this layer. It loves high temperatures and happily forms in lava, eventually crystallizing into the igneous rocks we find scattered across the Earth's surface thanks to volcanic eruptions. As olivine cools, it starts to crystallize. Sometimes these crystals are tiny, but other times they grow large and can be polished into beautiful gemstones used in jewelry or industrial processes like metal casing. But as we venture deeper, about 250 miles down, olivine undergoes a fascinating transformation. Here we encountered the layer that's called the transition zone. In the transition zone, the pressure is intense and the heat is on the rise. In this place, olivine morphs into exotic materials like wadleysite and ringwoodite. They show a lovely blue-green hue and a glossy sheen. While they're too rare and small for jewelry, they have a unique ability to hold water within their structures, not as droplets, but as hydrogen and oxygen components, making up to 3% of their volume. Later, it turned out that the transition zone is not just a pressure cooker for minerals, it's a giant sponge, holding a vast underground water reservoir. This was a groundbreaking discovery. You get the pun? This hidden water doesn't form an ocean as we know it, but suggests vast amounts of water are stored deep within the Earth. Volcanoes can help us learn more about life not only on our planet, but on others as well. In the fiery heart of Costa Rica's Poas volcano lies Laguna Caliente. This hydrothermal crater lake is among the most brutal environments on Earth. We've got a whole bunch here: scalding temperatures, toxic minerals, and water so acidic it can corrode metal. But despite all that, there's a few tough microorganisms that manage to thrive in these conditions. And this remarkable survival has caught the attention of scientists because it might just hold clues about life on Mars. Scientists are studying these extreme microbes. Turns out they've developed a myriad of genetic adaptations to withstand their harsh surroundings. They have genes that help them process everything, from sulfur and iron to carbon and bioplastic granules. All these things could be crucial in environments as challenging as Mars. NASA's Perseverance rover is currently exploring the crater rim of Jezero crater on Mars. Previously, we looked for Martian life signs in places like old stream beds and river deltas. However, the discovery of Laguna Caliente suggests that we should probably look for life in the remnants of ancient Martian hot springs as well. These spots might have once had the right cocktail of heat, water, and energy sources that are thought to be essential for kickstarting biology. Volcanoes can help planets in many ways, but they can also destroy life. Scientists believe that volcanic activity was one of the main reasons for at least 3 of Earth's 5 mass extinctions. Take the mass extinction of dinosaurs. We're used to blaming it on the Chicxulub meteorite, but there's a chance it could have been caused by volcanoes. The consequences of the eruptions can be horrifying. Mount Tambora, located on the Indonesian island of Sumbawa, erupted in 1815 and was the most powerful eruption ever recorded in history. This massive eruption was so strong it ejected between 8 to 11 cubic miles of material. It was so loud that the sounds of the eruption were heard as far away as Sumatra, over 1,600 miles distant. Before its catastrophic eruption, Tambora had been dormant for centuries, and its magma chamber slowly cooled and crystallized. This process built up immense pressure inside the volcano. It was eventually released in a series of terrifying events starting on April 5, 1815. The climax came on April 10th, when massive plumes of ash and pumice were thrown into the atmosphere. The aftermath of the eruption was dire. Tsunamis devastated the surrounding area. It's estimated that around 4,600 people passed away immediately from the eruption itself, with ash fallouts affecting air quality and water sources across the region. This event came down in history as the year without a summer. This was due to the vast amount of sulfur dioxide Tambora ejected into the stratosphere. It created a veil of aerosols that reflected sunlight and significantly lowered global temperatures. A similar thing happened to our planet 66 million years ago, during the dinosaur extinction. The sky turned black for months. I mean, I wasn't there, but that's what they say. In 2018, the most powerful underwater earthquake occurred between East Africa and Madagascar. There was a deep rift between the Earth's crust and the mantle. Hundreds of thousands of tons of magma came out on the surface of the ocean floor. After that, a huge underwater volcano with a height of 2,700 feet was formed near the coast of Madagascar. This is almost twice the height of the Empire State Building, and all this is hidden under the water. French scientists studied this place since it had regular seismic activity. When the geologists went on an expedition to the coast of Madagascar, they discovered this giant underwater rock, which was not here until recently. With the help of geological equipment, they discovered the earthquake happened deeper than usual, below the Earth's crust. Geologists created a special observatory to monitor the situation at this site in real time. Between February and May 2019, they recorded about 17,000 seismic activities below the ocean floor. Scientists had never recorded such deep earthquakes. This suggests that there are reservoirs and drainage systems inside our planet through which magma flows. It's like the veins and vessels of a living organism. The volume of lava the volcano spews at this place can be compared with the volcanic eruptions in the hottest spots of Earth. Perhaps this is one of the most catastrophic, but at the same time, beautiful events in nature over the past few years. To understand what can be beautiful about this, let's first figure out what an underwater volcano is and how it works. Inside our planet, there are incandescent liquid metals and molten rocks containing almost all the chemical elements from the periodic table. All this hot substance is called magma, which constantly flows in the planet's bowels. Anyway, magma is lighter than the surrounding Earth's crust, so it always tries to break out upwards. Fortunately, the surface of our planet is strong enough and doesn't allow magma to splash out. But sometimes it happens, and here's why. The Earth's crust consists of many solid parts, tectonic plates. These plates collide with each other because of movement. Imagine a massive picture of puzzles. Each detail of this puzzle is a tectonic plate, and they all are constantly moving. Sometimes one puzzle gets unhooked from another. When this happens, magma immediately spills out of the resulting gap. And these places of faults with flowing magma we call volcanoes. When such a volcano erupts, a new geology begins. A splash of magma shakes the ocean floor. Lava and ash erupt from the inside of our planet. It causes a release of destructive energy of incredible power. But thanks to the water, such a catastrophe can go unnoticed. More than 70% of the seismic activity associated with volcanoes occurs underwater, and almost no one notices it. But inside the water, there's a total mess. Lava heats the water and destroys the seabed. The ocean in this area boils, and large air bubbles rise up. But the enormous pressure of hundreds of millions of gallons of water suppresses the volcano's destructive power. Molten rocks of the Earth's crust are pressed against the seabed. The ocean blocks the consequences of the disaster, but sometimes the eruption gets to the surface. Such a case occurred in 2012. Vast pieces of pumice the size of a van began to float up in the southeastern Pacific Ocean. There were hundreds, even thousands of them. It was more like a group of unknown islands. Volcanic rocks scattered in the ocean over an area twice as large as New Zealand. Scientists used deep-sea sonar apparatus on the remote control to determine the full scale of the disaster. They studied the seabed for a long time and found 14 craters that released lava. The researchers saw that more than a third of the erupted volcanic material surfaced and scattered throughout the ocean. The rest was scattered along the bottom. It destroyed all marine life in the area. However, after the eruption of volcanoes, life is reborn like a phoenix from the ashes. Volcanic ash, lava, and soil around the volcano contain many useful elements and minerals. They nourish the soil and promote the development of microorganisms not only on land but also in water. That's why there's so much vegetation, flowers, and trees around volcanoes. and underwater volcanoes can eventually form natural islands. This is a long process, resulting from which a large piece of land comes out of the water. When magma goes out, the water immediately presses it to the seabed. The eruption can go on for a long time. The released magma raises the level of the seabed. After another 100, maybe 1,000 years, a new eruption begins. New magma flows lay a new layer on the surface of the previous one. Over millions of years, layer by layer, the volcano has been growing. It's slowly rising up because of constant eruptions. Some volcanoes may go out forever, and some continue to erupt. And then, one day, the level of volcanic rock reaches the surface in the form of a huge island. After many more years, the volcano may go out, and then life appears on the formed island. The destroyed seabed area is filled with animals, trees, flowers, and plants. These volcanic islands have unique ecosystems because they develop separately from all continents. Observing such islands helps scientists understand how life on Earth was born. There are hundreds of islands around the world that have appeared because of eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, and Iceland. Many of them are inhabited by people. They build villages and small towns there. The ground on such islands is fertile. Fruits and vegetables grow there. The water is filled with fish. Such places may seem like paradise, but at the same time, it's dangerous to live there because the volcano may wake up. One of the most famous eruptions occurred on the island of Ogashima, south of Tokyo. People built a beautiful city right in the crater of an active volcano, and in May 1785, the eruption began. No one expected this to happen. At some point, thousands of birds rose and flew away from the island, and then the ground began to shake. A heavy, low sound came from beneath the underground depths. Thick smoke escaped from the top of the green volcano. The mountain threw dirt, large rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People managed to evacuate, and then there was a long recovery. Locals rebuilt the houses and brought the city back. Almost 250 years have passed since that moment, and during this time, the volcano has never woken up. Despite the risk of a new eruption, people continue to live there. The population is growing since this place resembles paradise, and no one wants to leave it. There are thermal springs, dense jungles with rich soil, and many fish. Meteorological and seismological services constantly monitor the volcano's activity. Movements and fractures of tectonic plates create another natural disaster: destructive tsunamis. Unlike volcanoes, huge waves are formed when seismic activity causes the crust to move vertically, up or down. When this happens, water pressure shifts on the ocean floor, which releases energy. This energy pushes the water and creates a tsunami. By the same principle, you form a small wave when you throw a stone into the water. First, a small tsunami appears. Then it picks up speed and increases in size. Its height can reach the level of a 5-story building. It's heading for the coast and accelerating to 500 miles per hour. This is almost twice as fast as a Formula One race car. Millions of gallons of water, weighing thousands of tons, are getting closer. And now the wave reaches the shore and demolishes everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. Such tsunamis are a frequent occurrence on the coast of Japan. People have built massive shields near the land to stop the waves before they hit the shore. Still, in spite of all preparedness, somehow, nature always prevails.
There's something really bizarre going on at these 12 points scattered across the Earth. The vile vortices, as they're called, are these creepy spots over the Tropic of Cancer, the Tropic of Capricorn, and the North and South Poles, where weird forces seem to take over. You've probably heard of the most famous one, the Bermuda Triangle. It's believed that more than 50 ships and 20 airplanes have mysteriously disappeared in this area, which is located between Florida, Bermuda, and Puerto Rico. But what most people don't realize is that the Bermuda Triangle actually has 11 siblings, and these other spots can be even more terrifying. Let's start with Mohenjo-Daro. This was a thriving city located in what is now Pakistan. Built around 2500 before the Common Era, this urban center was once home to about 40,000 people. But then, suddenly, people abandoned it by the year 1700 before the Common Era. In the 1940s, an archaeologist discovered 39 human skeletons at the site, which fueled the theory that the city was invaded by some other civilization at some point. But honestly, it's hard to confirm that, since archaeology doesn't really explain the city's sudden destruction or the disappearance of its people. It's led to a bunch of bizarre theories. One of them talks about an ancient extraterrestrial race that might have lived there, and a malevolent wind that swept through the city. Another ancient city with a similar mystery is the Great Zimbabwe. Its construction began in the 11th century, and at its peak it housed up to 18,000 people. But for reasons we'll probably never fully understand, it was abandoned in the 15th century. Archaeologists were really interested in this place, and that's when things got even weirder. They found 8 of these birds, now called the Zimbabwe birds. These soapstone sculptures were found sitting on stone columns that were over 90 centimeters tall. Nothing like them has ever been found anywhere else, and their meaning is still a total mystery. Some think each bird represents a new king, but other theories suggest they were ancient animals very dear to the people who lived there. Adding to the mystery, local legends talk about a strange, short man who's sometimes seen wandering around, but he always disappears before anyone can get close. Then there's Easter Island, another one of the 12 vile vortices. It's located in the eastern Pacific Ocean, and it's famous for its nearly 1,000 enormous statues called moai. We still don't know what they mean, or how they were made. Some of them are almost 30 feet tall and weigh as much as 80 tons. Today, it wouldn't be that tough to move and carve these statues, but we're talking about a period between the years 1100 and 1680. So nobody really knows how they did it. Some specialists believe these statues were carried across the island, while others think they were pushed on log rollers. But the most bizarre theories suggest extraterrestrials were involved. Algeria is another land rich in ancient mysteries, and one of the most fascinating is something called the Jedars. These are 13 monuments with square stone bases and angular mounds, built between the 4th and 7th centuries. But the weird part is, no one knows their purpose. One of them had an inscription in Latin, but it was so worn down that the message was nearly impossible to read. The best guess so far is that these monuments were probably tombs for royalty, although no one knows exactly who was supposed to be buried there. What we do know is that there are many myths related to strange disappearances in the region. The next mysterious spot is located south of Tokyo in the Pacific Ocean, and it's called the Dragon's Triangle. Does that name ring a bell? Yep. Just like the Bermuda Triangle, this area is known for strange disappearances of airplanes and ships. One of the most chilling stories dates back to 1945, when a plane allegedly vanished. The pilot supposedly sent a radio transmission right before the aircraft disappeared, claiming that something strange was happening in the sky, like it was opening up or something. While this story is definitely eerie, the truth behind it and many other Dragon's Triangle legends is still up for debate. If you type Hamakulia Volcano into Google Earth, you'll find it located in Hawaii's Ring of Fire. But this place is so shrouded in mystery that it's hard to find much information about it. Some legends speak of unusual electrical energy being detected in the area, and there's even a story about an eyewitness who claimed to see a plane flying over it totally disappear from the radar. Another eerie spot is the South Atlantic anomaly, which is an area on Earth where natural radiation flows out of control. while this doesn't affect our daily lives on the surface, it has a pretty big impact on Earth's atmosphere. The radiation there is so intense that it can knock out the onboard computers of spacecraft and interfere with the data collected by satellites passing through the area. To deal with this, specialists had to add an additional shield to the International Space Station. The South Atlantic anomaly is also linked to a weird event that astronauts experience called cosmic ray visual phenomena. They've reported seeing random flashes of light or shooting stars out there in space, but it's all just some kind of illusion. From wild radiation to strange seismic activity. The Wharton Basin in the Indian Ocean is a place known for unusual tectonic events. In April of 2012, a massive earthquake measuring magnitude 8.6 hit the region. This was considered the largest intraplate earthquake ever recorded, meaning it happened within a tectonic plate rather than at its boundary. This caught the attention of scientists, who now speculate that the region might be forming a new boundary between the Australian and Indian plates. But for now, this is all still one big mystery. Now let's head to the Pacific Ocean. More specifically, to the New Hebrides Trench. This submarine trench is about 750 miles long and 45 miles wide. It formed when the Australian plate slid under the New Hebrides plate. There's no doubt that this is one of the creepiest and deepest spots in the ocean. The danger isn't just down in the deep sea either, as this trench has been connected to several earthquakes that affected New Caledonia and Vanuatu. This area also has some strange features. For example, when scientists explored it, they didn't find a single grenadier fish down there. This type of fish is one of the most common deep-sea creatures you would expect to see in trenches around the Pacific. So why aren't they around the New Hebrides Trench? Maybe they know something we don't. The two remaining vile vortices are the North and South Poles. These two are on the opposite ends of the planet, but they share one thing in common: strange disappearances. One of the most famous stories from the North Pole happened in 1897. 3 brave explorers set out on a journey to reach the North Pole using a hot air balloon. But they never completed their mission. Their mysterious disappearance remains one of the most intriguing, unsolved mysteries in the history of Arctic exploration. The South Pole is also known for similar mysteries. It's believed that hundreds of people may be buried beneath the snow and ice of the coldest continent on Earth. Even with all the advancements in technology and knowledge, the South Pole can still be extremely dangerous for anyone who ventures there. The temperatures can drop to almost minus 130 degrees Fahrenheit, and the winds can get up to 200 miles per hour. And that's definitely enough reason to stay away. Now that you're familiar with the 12 vile vortices, let me tell you something even stranger. If you look at a map, you'll see that these places are arranged in a way that looks pretty similar across the globe. Here's the weird part. If you connect these spots where unexplained events have occurred, you actually form the geometric shape of an icosahedron. This could be just a huge coincidence, but the fact that these mystery spots align with this shape makes them even more intriguing.
It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reached the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis, like the one in 2004, are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground. Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States, like the Klamath and San Joaquin, all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle megafloods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain's steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems